Hello there, I'm Ms. Lee. Today we're going to continue solving radical equations. So you should have some sort of idea on the general process of solving equations. So just to kind of summarize that, in general, when we're solving equations, you should be starting by isolating the radical if you can, and then undoing the radical, and then solving algebraically, and then checking your solution to make sure that it is not extraneous. Okay, so that's the general process, but we're going to walk through an example problem right now. Okay, so we'll do two actually. So our first example problem is going to be solve for x, for x, label any extraneous solutions. So what you see in this equation is that you have x plus 4 to the 1/4 power minus 2x minus 3 to the 1/4 power equals 0. And so I don't see any radicals here, yet we're talking about solving radical equations. So you should recognize that anything to the 1/4 power or anything to a fractional power is going to be a radical in some way, shape, or form. So 1/4 power means fourth root. So if you prefer radicals, you can rewrite this in radical form. If you prefer the fractional exponent, leaving it as the 1/4 power is perfectly fine. So we'll go ahead and rewrite it. So we have the fourth root of x plus 4 minus, and then the fourth root of 2x minus 3 equals 0. And remember, your first step would be to isolate one of the radicals. So isolate one of the radicals. It works out nicely here because it's equal to 0. And so when you isolate one of the radicals, you actually end up isolating both of the radicals. So we'll go ahead and add this entire radical to the other side. So we have fourth root of x plus 4 equals fourth root of 2x minus 3. Okay, so whichever radical you isolated, you want to undo. So we want to undo this fourth root. And in order to undo a fourth root, you take everything to the fourth power. And so if you think about that, that makes sense because it's kind of like undoing that exponent. So if you took this and you took it all to the fourth power, that would have an exponent up to the 1/4 power and then times 4. So the 1/4 times 4 becomes 1 and kind of like cancels out or ones out. So in this case, we're going to take both sides to the 4th power. So what we're doing is undoing the radical. And so this happens to undo both of the radicals. So we're left with an x plus 4 equals 2x minus 3, which is a standard linear equation. So you want to move all the x terms to one side and all of the constants to the other side. And so we'll add 3 to both sides. So add 3 to both sides, and you have x plus 7 equals 2x, and then you subtract the x from both sides. And so you get x equals 7. So a lot of you at this point say things like, oh, I'm done, x equals 7. But I want you to always show your work in checking your solutions. So never, ever forget to check your solution because you never know where there might be an extraneous solution. So basically when you like take both sides to the 4th power, or if you like square both sides or like multiply both sides by something with a variable in it, you may end up with an extraneous root. And so you always want to check your work whenever you do something like square both sides or take both sides to the 4th power. So I'm going to go ahead and plug 7 back into the original equation that was given to us. So you want to check it with the problem that they gave us to make sure that we actually solved that problem. So we have 7 plus 4 to the 1/4 power minus, and then you have 2 times 7 minus 3 to the 1/4 power equals 0. So you have 11 to the 1/4 minus, and then you have 2 times 7 is 14 minus 3, which is 14 minus 3, which is 11. So you have 11 to the 1/4 power here as well, and that equals 0. And so check. Therefore, our solution is, in fact, x equals 7. So we can box that. All right, let's try one more example, a little more complicated. So example 2. So we're solving for x and identifying any extraneous solutions. And we're doing something a little bit more difficult here. So we have x plus 5 minus the square root of, square root of x plus 5 minus the square root of 3x minus 8, and this all equals 1. Okay, so we're going to start with the same step. We're going to start by isolating one of the radicals. Okay, so we're going to isolate one of the radicals. And I personally don't like having extra minus signs rolling around. And so I generally take whatever is being subtracted and I add it to the other side. So I'm going to go ahead and take this entire radical and I'm going to go ahead and add it to the other side. So I'm going to put this to the other side so that we can isolate this radical. Okay, so the goal here again is to isolate one of the radicals. If you choose to isolate the square root of 3x minus 8, that still works, but I like to take the easier way. So we'll have the square root of x plus 5 equals 1 plus the square root of 3x minus 8. Okay, and then same step as before, we undo the radical or undo the isolated radical. So we'll go ahead and square both sides. Okay, so this is where a lot of you make your biggest mistakes. So a lot of you will think, well, this is addition, this is an exponent. I'm going to go ahead and distribute this exponent to here and distribute this exponent to here. That is not okay, and that is not allowed. Don't ever do that. So whenever you have two things added together and you're squaring it, you need to multiply it out, and you can multiply it out using a box, like we've done in the past. For example, in the past, if you had x plus 2 and then you squared that, would you get x squared plus 4? Can you square each of the individual terms? Well, no, you cannot. So you can't do that here either. Okay, so then we'll go ahead and simplify with a box. So the left side, we're going to end up with x plus 5. That's fine. On the right side, however, since this is something plus another something and then squared, you're going to have to use your box. So we'll go ahead and make a little box. So we have 1 square root of 3x minus 8, because that's 1 plus square root of 3x minus 8, and then times 1 and then plus square root of 3x minus 8. Okay, so then we multiply it out. So this is like our area model where you just multiply like each of the sides. So 1 times 1 is 1. 1 times square root of 3x minus 8 is square root of 3x minus 8. 1 times square root of 3x minus 8 is still square root of 3x minus 8. And square root of 3x minus 8 times square root of 3x minus 8, that's going to be 3x minus 8. Remember, if you take like the square root of something and you multiply it by the square root, you end up with itself. So like square root of 9 times square root of 9 is 9. Okay, so we'll go ahead and just add all this up. So like I said, on the left side here, we still have x plus 5. So we have x plus 5 equals, and then we'll go ahead and add this up. So since these two are the same, we can say we have two of those. So it's 1 plus 2 square root of 3x minus 8 plus 3x minus 8. So what you'll notice here is that we still have a radical in our equation. So we are going to have to repeat the steps that we just took. So we'll go ahead and again, isolate that radical and then undo the radical. So let's go ahead and isolate the radical. So I'm going to go ahead and add the 8 to the other side. So if I add the 8 to the other side, I'm going to have x plus 13 equals 1 plus 2 square root of 3x minus 8 plus 3x. And then we're going to subtract the 1 from both sides. So again, we're trying to isolate the radical, so I'm getting rid of everything that's around it. Okay, so then we'll subtract the 1 from both sides. So you have x plus 12 equals 2 square root of 3x minus 8 plus 3x. Ready? Then we subtract the 3x. So you have negative 2x plus 12 equals 2 times square root of 3x minus 8. And again, we're trying to isolate the radical. And since it is being multiplied by 2, we'll go ahead and divide by 2. So dividing both sides by 2. Remember, when you divide by 2, you need to distribute if it's a cross addition. Since this is being multiplied, we don't need to distribute. And so over on this side, we have the square root of 3x minus 8. And then over here, we have negative x plus 6. So did I successfully isolate the radical? I sure did. So we'll go ahead and undo the radical. So to undo this radical, since it's a square root, same thing as before, we'll go ahead and square both sides. Square both sides. And as we said earlier, if you have negative x plus 6 squared, you can't just take each one and square it. You have to make a box. And so we'll go ahead and make a box. Of course, over here, we're just undoing the radical, and so we'll end up with 3x minus 8. So let's go ahead and multiply out this side. Okay, so we multiply this out, negative x times negative x, that's x squared. Negative x times 6, that's negative 6x. Negative x times 6, that's still negative 6x. And 6 times 6 is 36. So we'll go ahead and add this up. You have x squared minus 12x plus 36. Of course, because there's two negative 6x's, that's going to make negative 12x. And then equals 3x minus 8. Now you'll notice that there are no more radicals. So we can go ahead and solve algebraically. So I'm going to go ahead and move all of the terms to one side because this looks like a quadratic to me. So I add the 8, subtract the 3x. So I have x squared minus 15x plus 44 equals 0. This is a quadratic. So I'm going to go ahead and see if I can factor it. So if you remember, you always want to check to see if a quadratic is factorable. So we make a big X, put 44 at the top, negative 15 at the bottom. Are there two numbers that add up to negative 15 and multiply to 44? There sure are. It will be negative 11 and negative 4. So we have x minus 11 and x minus 4. So we have x equals 11 and x equals 4. Looks like we're done, right? Of course not. You have to go ahead and check these answers. So we want to go ahead and check these answers using the original equation. So we'll go ahead and check your answers. So check. And so for x equals 11, we'll go ahead and plug it into the original equation, which was square root of x plus 5, so 11 plus 5, minus the square root of 3 times 11 minus 8. And does this equal, question mark, does it equal 1? So square root of 11 plus 5, that's the square root of 16, minus the square root of, well, 3 times 11, that's 33, minus 8, that's 25. So 33 minus 8, that's 25. So we have square root of 16 minus square root of 25. Does this, question mark, does this equal 1? So we have 4, square root of 16 is 4. Minus square root of 25 is 5. And the question is, does this equal 1? So negative 1, does that equal 1? Well, I hope you're saying in your own house or wherever you're at right now, no, absolutely not. This does not equal, and so therefore x equals 11 is not a solution, and we call it extraneous. Okay, so going back to the previous page, so x equals 11 is not a solution, and it is an extraneous solution. So x equals 11 is extraneous. Now let's go ahead and check x equals 4. You plug it into the original equation, so substitute for x, substitute 4 for x. We have 4 plus 5, or square root of 4 plus 5 minus the square root of 3 times 4 minus 8. Does that equal, question mark, does that equal 1? The square root of 4 plus 5, that's the same as square root of 9 minus, well, 3 times 4, that's 12. 12 minus 8, that's 4. So we have square root of 4. Does that equal, question mark, 1? So square root of 9 is 3 minus the square root of 4, that's 2. Does that equal 1? Yes, it does. It sure does. So x equals 4 is our only solution. X equals 11 is our extraneous solution. And there you have it. That's how you solve for an equation with 2 radicals in it. Happy day.